Hello students, hope you are doing well. Let's start this topic, motion in one dimension. Under this topic, we'll be studying about distance and displacement, speed, average and instantaneous speed, velocity, that also average and instantaneous, acceleration and equations of motion, differential equations of motion, graphs, and motion under gravity. So let's start with the basic definition of distance and displacement. What is distance? Distance is the actual path length of the particle from initial to final position of the journey. What does it mean? It means that you can see the figure that is shown here. A person starts from the starting point. You can see the dotted line. He goes along the dotted line and comes to the end point. So the length of the total path covered by this person is called the distance. And then what is displacement? Displacement is the shortest distance between initial and final position of journey. You can see here the black line. So this is displacement. I can see that wherever he is going, he might be going around the world and coming back to this point. The displacement would be only from starting point to end point. Now let's look at the properties of these things. Now distance depends on the path taken, because distance is along the path. We measure the length of the path. It depends on the path taken. Now let's say if the person takes a path something like this, then his distance would be different. So distance depends on path taken. Distance does not depend on initial and final position. So it need not be depending on actually initial and final positions. It only depends on the path taken. Now distance does not have a specific direction. You can see that the distance doesn't have a specific direction because the person is moving in different direction. Here he is moving like this, here he is moving like this, here he is moving like this. So I can't say that the person is having a constant direction. So distance does not have a specific direction. Now let's come to displacement. Displacement does not depend on path taken. So whatever is the path taken, I'll call this path 1 and I'll call this path 2. Both the cases, the displacement is same. So displacement does not depend on path taken. Displacement only depends on initial and final positions. You can see that this is the initial position, the start position, this is the end position. Wherever he goes, he might be going along this path, this path, this path, all the paths, his displacement would remain same. And you can see that displacement has a specific direction. Now it is having a specific direction. What is the direction of displacement? It is from starting point to final point. This is the direction of displacement. Now let's look at this. Let's take a situation where a body is moving along a straight line, and you can see that there is a scale shown here. Just to understand, let's assume that the body starts from 0 and moves towards positive x. It moves 2 meters and then it comes back to this final position. Now what can be the distance of the object? I'll take case 1. Case 1, what is the distance? In first case, distance is 0 to 1 meter, distance is 1 meter. In second case, the body has started from 0 and gone to 2 meters, so distance is how much? 2 meters. And by the time it reaches the third case, that is final one, so it has traveled 2 meters forward and then it has come back to this point. So 2 meters forward and 4 meters backward. So the total distance is how much? 6 meters. I hope it makes sense to you. So first case distance is 1 meter, second case distance is 2 meters, and third case distance is 6 meters. Now let's look at displacement. First case, final position is 1 meter, initial position is 0. So displacement is final position minus initial position, that is equal to 1 minus 0, that is 1 meter. Second case, again final position is 2 and initial position is 0, so 2 minus 0, that is equal to 2 meter. Third case, initial position is 0 and final position is minus 2. So I'll say final minus initial would be equal to minus 2 minus 0, that is equal to minus 2 meter. So you can see that for all the three cases, distance and displacement have different values. In fact, for the first two cases they are same because the body is moving in a straight line. So I can conclude that when a body is moving in a straight line without turning back, or if the direction of body doesn't change, then distance of the body is equal to displacement of the body. Now let's look at this situation. Let's say an object goes from a point A here to point B here. The radius of the circle is r. Then the distance would be this arc. So how much would be the length of the arc? So the total perimeter is 2 pi r, and it is 1/4 of the total perimeter. So this will be equal to how much? Pi r by 2. Now let's come to displacement. Displacement is this shortest path. Now this path is the displacement. So if this is r, this is r, this would be under root of r square plus r square. That is equal to how much? That is root 2r. Displacement would be equal to root 2r. So now let's look at the next quantity. The next quantity that we have is speed. And again, speed, what is speed? Speed is the measure of distance covered in unit time. Whatever is the distance covered in unit time, that's called speed. And speed is given as ratio of distance covered by time. Speed is further classified into two categories, that is average speed and instantaneous speed. Average speed is the ratio of total distance covered to the total time taken. So the total distance covered to the total time taken is average speed. And what is instantaneous speed? Speed at a particular instant of time. For example, let's say you're going from home to some other place which is 10 kilometers, and let's say you take around 30 minutes to go there, or let's say 1 hour for easy calculation. So if you're taking this distance, I'll say distance equal to 10 kilometers and time equal to 1 hour. Then average speed would be equal to how much? 10 by 1, that is equal to 10 kilometers per hour. Now we are not bothered about the places where you applied brake or the places where you accelerated. So if I take a graph, if I take this as 10 kilometers per hour, I see that the average speed is taken as the ratio of total distance by time. But if you look at the actual path, actual speeds, you might have started at home, then you might have increased the speed, and then maybe due to some hindrances or due to the traffic, you decrease the speed and again instead increase the speed. So speed at different points is different. So speed at this particular instant is different. This particular instant is different. So speed at particular instant of time is called instantaneous speed. So I hope you understood the difference between average speed and instantaneous speed. So again, the same thing, I'm writing it again. Average speed is given by total distance. It is given as the ratio of total distance by total time. And instantaneous speed is given by the differential of the position. I taken it as dx by dt, but otherwise if you take displacement as s, then it can be written as ds by dt. And under what condition average speed would be equal to instantaneous speed? Average speed would be equal to instantaneous speed when the object is moving with a constant speed without changing direction. So if the object doesn't change its direction and maintains its speed as constant, then average speed is equal to instantaneous speed. I hope you could understand the basic things, that is distance, displacement, speed. And within speed, what is average speed and what is instantaneous speed. Thank you very much.